Hi ladies and gentlemen, welcome back. Today we are going through the lesson on dividing and writing our remainder as decimals. So in our do now though, the instructions do say write the remainder as a fraction in lowest terms. This is a review from what we've done before. So let's go ahead and do our division for number 1. I can't make any groups of 4 out of 3, but I can make 9 groups of 4 out of 37. 9 times 4 is 36. And when we subtract, we have a difference of 1. So I'm going to bring the 3 down. 4 goes into 13 3 times. 3 times 4 is 12. We have a difference of 1 when we subtract. We're going to bring the 7 down. 4 goes into 17 4 times. That's 16. And when we subtract, we have a difference of 1. So we're going to bring the 0 down. 4 goes into 10 2 times. That's 8. And when we subtract, we have a difference of 2. So our remainder becomes our numerator, and the divisor here, 4, becomes our denominator. And 2/4 can be divisible by 2 over 2, which gives us a fraction of 1/2 in lowest terms. So our quotient is 9,342 and a half. All right, our next question. 942 divided by 15. We can't make any groups of 15 out of 9, but we can make groups of 15 out of 94. And I'm going to take a guess here that it's going to be 6 groups. Let's try it. That's 30. 6 times 1 is 6, plus 3 is 9. So that's pretty close. It goes in 6 times. We have a difference of 4 when we subtract 94 and 90. Then we're going to bring the 2 down. 15 goes into 42 twice. 2 times 15 is 30. And when we subtract, we have a difference of 12. Again, our remainder, 12, goes in the numerator, and 15, our divisor, goes in the denominator. 12 and 15 are both divisible by 3, so we're going to reduce it to lowest terms. So that gives us lowest terms of 4/5. So 62 and 4/5 would be our quotient for number 2. All right, let's keep going. Now we're going to do a couple of problems where we're going to write the remainder in decimal form. So we're going to start off our division just like we did earlier. I can't make a group of 8 out of 5, but I can make 7 groups of 8 out of 57. 7 times 8 is 56. And when we subtract, we have a difference of 1. So I'm going to bring the 8 down here. 8 goes into 18 2 times. That's 16. And when I subtract, we have a difference of 2. So at this point, to write our remainder in decimal form, we need to add a decimal point to the right of the ones place. That's to the right of the 8. And then we can add some zeros, 1 or 2 or 3, it's up to you, to continue bringing down and dividing. So we're going to bring that first 0 down to make the 2 into 20. I'm also going to bring the decimal point up straight into the quotient before we keep dividing. You could do it at this point or at the very end. I would suggest once you add the decimal point, you bring it up and make sure your numbers are all lined up. So 8 goes into 22 times. That 2 goes right after the decimal point. 2 times 8 is 16, and when we subtract, we have a difference of 4. So we're going to bring the last 0 down, or another 0 down. 8 goes into 45 times, and 5 times 8 is 40. So we can stop bringing the zeros down and dividing once we have 0 remainder, or once we see a pattern happening. So in this case, we have 0 remainder, we can stop. We didn't need the extra 0 that I had put on at the end there. All right, let's try number 2, 2,288 divided by 6. So I can't make a group of 6 out of the 2, but I can make 3 groups of 6 out of 22. 3 times 6 is 18, and when we subtract, we have a difference of 4. I'm going to bring the 8 down to make it 48. 6 goes into 48 8 times. 8 times 6 is exactly 48. And a difference of 0. We're going to bring the last 8 down. 6 goes into 8 one time. That's 6. 1 times 6 is 6. And we have a difference of 2. So again, we have a remainder here. We're going to add a decimal point just to the right of the 8 in the ones place and add a 0 or a couple of zeros. It doesn't change the value of our number if I add 1 0, 2, 3, 10 zeros. So it's up to you. We're also going to bring the decimal point up into the quotient before we continue. And then my next step, we're going to bring the 0 down so we can keep dividing. So 6 goes into 20 3 times. That's 18. And we have a difference of 2. If I bring the next 0 down, you'll notice we have 20 again. 6 goes into 20 3 times, and that's a difference. I'm going to subtract 18 for a difference of 2. If I bring the 0 down again, we're going to have 20 again. So we're going to have this pattern that repeats 20 minus 18, 20 minus 18 over and over and over, and the 6 goes into the 23 times. So this 3 is going to repeat over and over forever. And to show that, we're going to use a bar over the 3. So we can write it two ways. I can write it as 381.33 with a bar over the last 3. We can write it with 1 3 that repeats, or we can write it with more than 1 3 that repeats and put a bar over both of those 3s. All of those are acceptable. What would not be good form, I'm going to say no, 381.33, where I have a bar over the first 3 only. So why is that not good? Because the bar over the 3 tells us those 3s repeat until infinity, forever. So to have a number that comes after infinity or after forever does not make sense. So this is not an appropriate form. All right, let's try question number 3. 1 divided by 3. So a lot of times we think the bigger number is always going to go on the outside of our long division. Not true. So I'm going to rewrite it properly here. And when we're changing it into the long division sign, the position of these two numbers is going to switch. The 1 is being divided by the 3. So let's do that division. I'm just going to give myself some more room here. So clearly I cannot make a group of 3 out of the 1, so we're going to put a 0 just above it. And then I'm going to add a decimal point like we did in the questions earlier, and some zeros. 1, 2, or 3, it's up to you. I'm going to bring the decimal point up into the quotient, and now I can do the division. 3 goes into 10 3 times. 3 times 3 is 9. And 10 minus 9 is 1. You'll notice I'm ignoring that decimal point and pretending that 1.0 is 10. All right, if I bring a 0 down, it becomes 10 again. 3 goes into 10 3 times. And again, 3 times 3 is 9. So we're going to have this pattern repeating over and over and over again. So to show it, we're just going to put a bar over the last 3. All right, let's take a look at a word problem here. Miss Smith bought a pack of construction paper that has 125 sheets. If she divides it evenly between 2 classes, how much paper will each class get? So we're going to take our 125 sheets and divide it by 2. So 2 can't go into 1, but it can go into 12 6 times. 6 times 12 is 12. And when we subtract, we have 0 difference. We're going to bring the 5 down. 2 goes into 5 2 times. 2 times 2 is 4. And then we have 1 remainder. So now we're going to add a decimal point to the right of the ones place along with the 0. The decimal point has to come up into the quotient. And I'm going to bring the 0 down to make that 1 a 10. And 2 goes into 10 5 times. All right, so each class will get 62 5/10 pieces of paper, or 62 whole pieces and then another half. All right, so just to review with the bar notation for repeating decimals. A repeating decimal is a decimal whose digits repeats in groups of 1 or more numbers. So bar notation, in repeating decimals, the line or bar placed over the digits that repeat. So for the first example, we have 0.33333. The 3's are going to go on, and like we saw earlier, we're going to put a bar over the 3. For the next example, we have 0.121212, and those 1 and 2's are repeating. So in this case, we're going to put a bar over the 1 and the 2 because both of those digits repeat. And the last example, we have 11.3858585. It's the 8 5's that are repeating, not the 3, so the bar goes over just the 8 and the 5. All right, if you have any questions, please message me directly, or we will talk during our Google Meet. Hope you have a great day. Bye-bye.